Hi folks, we're going to take a look at this problem here where they're asking us to solve this logarithmic equation. So here we've got three different logarithmic expressions, so the goal is to try to bring them all into one expression. Now here I notice that there's no coefficients in front of any of these logarithmic expressions, so I can go ahead and use my first and second law of logarithms. Now I could do this all in one step. I'll do it in two steps, but eventually, as you get more comfortable, you should be able to perform these all in one step. So first of all, I see this addition, and we know that the sum of two logarithms is the logarithm of the product of those inputs. So x minus 1 times x minus 2. And then here we still have minus log base 5 of x plus 6. All right, and so now I've got the difference of two logarithms, and that's equivalent to the logarithm of the quotient. So log base 5 of x minus 1 times x minus 2 divided by x plus 6, and that's equal to 0. Okay, and this is the format we're looking to find. Okay, one single logarithmic expression equal to some number, so now I can take this and rewrite it in exponential form. Okay, so we've got x minus 1 times x minus 2 over x plus 6 is equal to 5 exponent 0. Okay, which of course is 1. And now what we've done is we've turned this logarithmic equation into a rational equation. So I'm going to solve this by multiplying both sides by the lowest common denominator. So here, this numerator, I might as well multiply it out. So we have x squared minus 3x plus 2 equals 1 times x plus 6, so just x plus 6. All right, so now bring everything to one side. X squared, that's going to be minus 4x. 2 minus 6 is minus 4. All right, now taking a quick look here, we see that this is not factorable, so I'm going to use a quadratic formula. So x is equal to negative 4, so 4 plus or minus square root of negative 4 squared, which is 16 minus 4 times 1 times negative 4 over 2. So we've got 4 plus or minus 16 plus 16, root 32 over 2. Excuse me. And I don't mind if we leave it like this, but we might as well simplify it here. So here 32 is 16 times 2, so the square root of 16 is just 4. So that becomes 4 root 2. And now we can keep simplifying, divide both of these numerator terms by 2, so 2 plus or minus root 2. Okay, oh sorry, 2 root 2, because the 4 is divided by 2. Okay, so now this is where it might not be a bad idea to approximate, even though I don't want the final answers given in approximated form, since there's nothing that asks us to do this, but I'm doing this so that I can more easily check my original equation. Because remember that when we're dealing with a logarithmic equation, these are the solutions to this quadratic equation we transformed it to, but it's this initial equation that we actually need to solve. So here we got 2 plus 2 times root 2, okay, and that's 4.83. Okay, and then we've got 2 minus 2 times square root of 2, and that's negative 0.83. All right, and so when we take a look at our original equation, we can see that this first one is perfectly fine, because even though I have a couple of subtractions, they still remain above 0. But if I were to put 2 minus 2 root 2, which is approximately negative 0.83, right away in this first one I see that it's not a valid input. Okay, so here we're going to give our final answer is just going to be 4 plus, sorry, we had simplified it, so 2 plus 2 root 2. Okay, and I guess we can say in brackets, since 2 minus 2 root 2 is an extraneous root. Okay, and why? X minus 1 will be less than 0, okay, in this first expression. All right, so just to recap, Step one is to realize that we need to bring this all into one single logarithm. Step number two is to ensure that we can actually apply our logarithm properties right away. So for example, had I had a coefficient in front of this logarithm, I'd have to first use the ski-slope rule to bring it into the exponent here. So I'm only allowed to add or subtract individual logarithms. And then from there, by transforming it into exponential form, I was able to solve it as a quadratic equation. But lastly, don't forget to always check that your answers, which are generated by the quadratic equation, actually fit the original equation. Okay, that's it for this one.